Welcome to our service tonight, a celebration of James Bedford Day. I'm Neil Vandery, and I'm your officiator here at the Church of Perpetual Life. We are streaming live from Florida, and we will be joining Ben Best live in New York City shortly. On the 12th of January in 1967, Dr. James Bedford became the first person to be cryonically suspended and remain in suspended animation at Alcor. And we have a wonderful presentation tonight with Ben Best. Our regular service this month will be Thursday, January 26th, and we are excited to have Brian Clement from the Hippocrates Health Institute in Palm Beach for our presentation. That's at 7 p.m. Eastern Time on January 26th. Ben Best was the president and CEO of the Cryonics Institute, one of the world's largest cryonics organizations, for 9 years, ending in 2012. Ben is a well-known activist in cryonics and life extension advocate. He holds undergraduate degrees in pharmacy from the University of British Columbia and physics and computing sciences and finance from Simon Fraser University in British Columbia, Canada. Ben is also certified as a professional registered parliamentarian. He currently travels the world attending age reversal conferences and meeting with researchers working to reverse human aging. Welcome Ben Best as we celebrate James Bedford Day.
Okay, that's me. And this is the outline of my presentation. It's actually three sections: a remembrance of James Bedford, an update on the COVID-19 pandemic with emphasis on technology, update on Cryonic Events and technology, and I'll have question period after the end of each section. I had a stroke, and so my voice is slurred, but most people seem to be able to understand me, and I hope my audience will be able to understand me as well. So he was the James Bedford's been in liquidation for 56 years, and he was preserved at the age of 73. January 12, 1967, died of cancer, and he's currently being stored in liquidation by Alcor Foundation. And this is a guy who did it, or was in charge of the whole thing, TV repairman turned president of the Cryonic Society of California. He wrote several books on the subject. Actually, froze the first man is literally accurate, but actually there's a woman who was frozen before James Bedford in 1966, but she was removed by her relatives later. Anyway, there's a team that did the preservation, but he was in a nursing home when he deteriorated, and his physician was called and was able to do a pronouncement. Bedford died 2 weeks earlier than he was supposed to. And but having his physician available, there was a prompt pronunciation of death, which sometimes people still don't get in these days. Anyway, they dumped ice on Dr. Bedford and administered artificial respiration and summoned Dr. Bruno and Robert Nelson to do the perfusion. There was supposed to be perfusion equipment to replace the blood with medical grade antifreeze, but the perfusion apparatus wasn't ready, so Bedford was just injected 50 to 100 times through the carotid arteries with the MSO and Ringer solution. So it may have been some replacement of his blood. Anyway, he was placed in dry ice for several days before being transferred by his family to liquidation at Cryonic Equipment Corporation. Now, Cryonic Equipment Corporation was just intended to be, in those days, people thought cryonics would soon be a booming business. And, they make a lot of money if you got in the bottom four. But after 2 years, they realized that was not the case. And so Cryonic stopped providing service. And so the Bedford family transferred Dr. Bedford to a cryogenics manufacturer in California. And then briefly also at TransTime, but the but was removed because of high cost, and finally transferred to Alcor Life Extension Foundation in 1982, and that's been where he's been ever since. And he was not interested in Robert Nelson of the Cryonic Society of California for more than a few days because they didn't trust Robert Nelson, and with good reason, all the CFC patients ended up thawed or buried due to financial mismanagement, and it was a disaster to cryonics. But anyway, Bedford was the one patient that's been retained all these years, and examination of his body indicated that he was been well preserved all these years. So if there's any questions on this section, I can take them now. And if not, I will proceed on an update on COVID-19. And this is not the stuff you're going to see in mass media. I'm going to go into very good, strong technical detail. I'm going to try to make it very clear, though. I've got lots of illustrations which will demonstrate what I'm talking about. Anyway, the virus that causes COVID-19 is a single strand of RNA, and the virus enters cells, takes over the cell's machinery to manufacture the virus, and cause the cell to release the virus and infect other cells. It's got a spike protein with two components. The S1 component binds to the cell, and the S2 component fuses to the cell. And there's a receptor binding domain on S1. So it's mainly ACE2 on lung cells was the original attachment of the virus. And antigens antigen is a term the antigens are components of viruses and bacteria that causes an immune response. And the primary target for COVID vaccines is the spike antigen. And all the SARS-CoV-2 variants involve modifications of the spike protein, but other modifications as well. So that's what coronavirus is called corona because it looks like a crown with all these spike proteins, and this is spherical shape like a crown, and okay, I mentioned that. Anyway, this shows the receptor binding domains, two components of the S1 spike and also the S2 spike that does the fusion. And this is a graphic illustrating on the right, you see the ACE2 receptor that the virus binds to. We've got the receptor binding domain. The S1 is what attaches to the ACE2, and the S2 component of the spike is behind that. And this is another. So it's not enough for the attachment to the H2 receptor. The virus has to bind to the cell membrane and fuse the cell membrane and allow the virus to enter. And for that, it requires the TMPRSS2 protein on the cell wall. So there's two ACE2, and ACE2 causes the attachment, and the TMPRSS2 allows the cell to enter. And this is a more detailed indication of the process. First, the ACE2 binding on S1, the S2 gets released, and over on the right side of the picture, you see the receptor binding domain drifting away, and the virus with the S2 protein fusing to the cell for entry. And this is another picture showing pretty well the same thing. And another picture showing pretty well the same thing. So ACE2 actually has a natural function. It prevents against ACE activity. ACE is the angiotensin converting enzyme, which constricts blood vessels and raises blood pressure. And the ACE2 enzyme dilates blood vessels, lowering blood pressure. And the blockage of ACE2 by the virus allows excess ACE activity, thereby causing people who get the COVID virus to suffer from high blood pressure frequently. But we don't even know what the TIMP-RS2 natural function is. Experiments of knocking it out in mice indicates we don't know what it does. ACE2 declines with age, causing higher blood pressure, which in normal older people have higher blood pressure, partly because the ACE2 decline with age. And also diabetes and cardiovascular disease causes ACE2 to decline. So you might think that with fewer ACE2 receptors, there would be protection against the virus, but actually even tiny amounts of ACE2 can cause entry into the cells if the TIMP-RS2 is present. So anyway, there's another way of entry for the virus, and that's by endosomes. And once it enters the cell, the spike protein is cleaved by capsin A, which requires acidification, and hydroxychloroquine can inhibit the acidification. But although this has been seen in the lab, at least initially, the TIMP-RS2 entry was much more common, and hydroxychloroquine has not been shown to be effective therapy. So this example of showing a picture of the endosome just engulfing the virus entirely and bringing it into the cell, and the furin enzyme cutting the spike protein, and here's the whole process showing the two ways of entry of the virus into the cell, and also the release of the virus from other cells, infecting other cells, and it's a circular process. The first variant, the Wuhan strain, was the original strain that emerged in Wuhan, China, and the very first variant called D614G emerged in late January of 2020, evidently causing improving the S1 spike protein ability to bind ACE2, and increases transmissibility without increasing severity, disease severity, and it soon replaced all the current variants incorporate the D614G mutation. So that shows you the timeline. January 2020 is when the virus was first identified, and very soon after that, the D614 basically took over all of that. And then we've had later variants, mutations. We had the alpha variant, the beta variant, and the delta variant. It's roughly sequenced along with a lot of other variants, but anyway, this shows the pattern of, you can see the coloring shows the timeline of the variants emergence and dominance, and it was in the alpha was the dominant variant in the spring of 2021, but by summer of 2021, delta replaced alpha, and both increased infectivity in the receptor binding domain, but the delta better evaded the immune system, and also delta is most severe variant we've encountered. Delta is the most severe COVID variant that's come along, much more severe than the current variants in terms of the problems it can cause. And this shows you the relative closeness, the genetic closeness to the Wuhan strain. which beta is pretty the farthest, and alpha and delta are pretty close. And so that indicates somewhat that what the vaccine's powerfulness, because the initial vaccines were all developed against the CD614 variant, which is before the alpha, delta, or beta, and all these other variants emerged. But it's still, the vaccines are still effective, but they don't precisely hit the target. So the original vaccines were 95% effective against the D614 variant, but then only 87, 97, 94% effective against the alpha variant, 72 to 75% effective against the beta variant, and 88% effective against the delta variant, indicating the closeness to the original Wuhan strain makes beta less vulnerable to the vaccines. So the way these vaccines work, I'll talk about the mRNA vaccines. They're delivered. The virus is an mRNA, but this is a modified mRNA to cause spike proteins to be formed in cells and cause as antigens to result in an immune response. And but we need to protect these liposomes from the immune clearance by putting this polyethylene glycol on the surface. So anyway, these vaccine liposomes fuse with cell membranes similar to the virus, but and then to deliver the modified messenger RNA to the cell so they can make artificial spike proteins. And so these spike proteins are manufactured by the cell, and they appear on the surface of the cell, and then result in an immune response, the immune response against the virus. And okay, so that's just what I said. So I should also mention that the mRNA virus isn't the only kind of virus. The one that in China, coronavirus, is Sinopharm. They're only inactivated the virus with a chemical that enters the virus and damages the RNA in the cell. So these are basically damaged viruses. This is the way polio and measles and all the other vaccines in the past have been made, is by damaging the virus and putting damaged components of the virus into the cell. Polio and rabies vaccines are all inactivated viruses. So anyway, so there's one advantage, supposed advantage of this method is the vaccine isn't just against the virus, the spike protein, it's against all the other possible antigens, spike, nucleocapsid, membrane, envelope. So there's all these other targets that theoretically it would have a broader spectrum. But in practice, that's not the case. China will not allow non-Chinese vaccines into China. They've only recently been developing an mRNA vaccine. The comparison is made between the coronavirus and the Pfizer mRNA virus, 2 doses for people over 60. Actually, this is Omicron testing, but 2 viruses, 2 doses of the coronavirus is about 70% effective, as opposed to 90% effective with the Pfizer RNA virus. Now, if you get 3 doses of either one into people, they're actually almost all entirely effective. But I think very few people in China have had 3 doses of vaccines. So it's not helping them. Anyway, here's just a mention of the Sputnik 4 vaccine, which has adenoviruses. It's been shown effectiveness, but it has side effects, and it has been authorized by the EU, the USA, or a lot of other countries. So this is a worldwide, January 22 indication of the worldwide use of the different viruses. And actually, the coronavirus was widely used in South America and the Middle East and several other places. So frequency of side effects, local pain, fatigue, fever, headache, swelling, so forth. Anaphylactic shock is the worst side effect, and that's the Pfizer is worse than Moderna in that respect. It's extreme immune response, and it can be life-threatening. And that's why when you get your vaccination, you're required to wait 15 minutes before leaving, so that they can make sure you haven't had an anaphylactic shock and give you epinephrine to prevent it. And and actually, some people actually develop COVID-19 after the vaccination, but it's very rare. Even death occurs, but that's also extremely rare. And all these people who had these severe outcomes had at least one risk factor. You know, they had diabetes, suppressed immune system, chronic disease of the kidney, or something. No deaths of people who received additional vaccine. So even though people with serious health problems are the ones who I guess most have to worry about something going wrong with the vaccine. Now, these also, the effectiveness declines with time. It shows days after immunization, the vaccine effectiveness declines, and Moderna effectiveness declines the least, as shown in this diagram. But the boosters restore this decline back to pre-boost, back to the levels of before the decline, actually even above before the decline. So there's such a thing as long COVID. Now, long COVID is a condition in which the virus can no longer be detected. Virus and antibodies can no longer be detected. So if you get a PCR test and it's negative, that doesn't mean that your symptoms are gone, because initially the virus enters the body through the lung and the nasal passages, but it also affects other organ systems. And eventually, after gaining entry in the body, it affects all these other organ systems. And so we get, and after the virus is gone and the nasal and lung symptoms are gone, these other systems persist. And fatigue and headache are the dominant systems, but actually long COVID is a highly, there's no one disease that's long COVID. It depends on what your organ systems are affected. So it could be the vaccination infections long COVID with more doses, providing more increased protection. So the Omicron variant contains it appeared in November 2021. It has more than 50 mutations in the genome and more than 30 mutations in the spike protein. And the large antigenic distance between Omicron and previous variants reduced vaccine effectiveness, resulting in more infections amongst vaccinated persons. This is called breakthrough infections. You've been vaccinated, but you get a breakthrough infection because the vaccination basically doesn't work. And notably, Joe Biden were fully vaccinated, and Fauci was fully vaccinated, and they both got breakthrough infections. So the vaccinations were no protection against Omicron initially. Omicron mainly uses the endosomal route, which I described also, rather than using the spike proteins, and it mainly enters through the upper respiratory tract rather than the lung. And so that's a really an advantage, because the lung symptoms, were what was what causing the fatalities from COVID-19, and the nasal symptoms are they make it much more easy to, when you sneeze and so forth, it makes it much more transmissible, but affecting your upper respiratory tract is far less life-threatening. And but anyway, within 2 months of emerging, the Omicron, which is first called BA1 in the beginning of 2022, was the dominant COVID variant in the world. And as I say, the Omicron variant was designated BA1 subvariant, and it was 2.2 times more transmissible than the previous COVID variants. And it replicates more in the bronchus, as I mentioned, and whereas Delta and the other previous variants were replicating more in the lungs. And so replicating in the bronchus means it's more transmissible by breathing and speaking and so forth. So we have this benefit of the less severe symptoms and the hazard of the more transmissible. And this was comparing initially in the beginning of 2022, compared Delta with Omicron. Delta had a lot more hospitalizations, a lot more deaths, and so forth. But anyway, Omicron was 98% of all, early in 2022, of all COVID-19 infection. So I should mention the R0 value, which is quantifies how many people are infected with an infected individual will infect in an immune naive population. So seasonal influenza is 1.3, common cold 2 to 3, measles 12 to 18. The original Wuhan strain only 2.9, Delta 5.1, Omicron B2, which is followed the B1 9.5, and the B7, which is currently rampant in China, 18 to 20. 2 doses of the vaccines against Omicron and Delta. It shows that the Delta is the vaccines are more effective. These are the bivalent vaccines, I believe. 2 doses. BA1 quickly gave birth to BA2, and that spawned all these other variants. The BA2 subvariant is even more prolific than the BA1, and spawning subvariants with a higher R0. And so there's the family tree, and we see the Omicron BA1, BA2 is spawning the most descendants, and including BA5, and then BQ1 and XBB, and all sorts of other variants. And so September 2022, bivalent mRNA vaccine was introduced in the USA. It was against the original Wuhan strain, plus the BA4 and BA5 spike proteins. And it's bivalent because it's Omicron and Wuhan. That's the 2 valents. And it offers increased protection against the Omicron BA5, but doesn't prevent breakthrough infections against the subvariants of BA5. And I mentioned there's a lot of subvariants. The bivalent booster gives 64% protection against infection by BA5, lasting 10 weeks, but protection against severe infection or death is much greater and more long-lasting. And neutralization antibodies from one bivalent booster were roughly twice as effective against these other subvariants than two monovalent mRNA boosters. So this is the current, this is actually a week ago, current, showing the subvariant trends in the United States. And you see the XBB 1.5 is taking the world by storm in terms of its proliferation. This is shown that this was as of January 7th. I looked at the data as of today, January 14th, and XBB 1.5 accounts for 40% of all the COVID infections in the United States, and actually about 80% of the infections in the northeast of the USA. So if you're going to get infected with COVID, it's going to be in the northeast, and probably the rest of them. It's just a matter of time before you get XBB. Anyway, XBB is a subvariant of BQ1 or subvariants. Monoclonal antibodies against BA2, BA5 has been shown to be ineffective against the BQ and XBB. The BQ1 subvariants cause less severe infection, but are more transmissible than the other Omicron subvariants. So we have this trend of being less harmful, less disease-causing, but more transmissible, which is a good thing, really. And actually, some authorities recommend trying to prevent symptomatic infections against healthy young people, vaccines against strains, which could disappear within a few months. The XBB.1.5 is more transmissible subvariant of XBB, and it replicates 40% faster than BQQ1, so it's taking the world by storm. And it accounts for more than 70% of infections, but it's probably higher than that by now in the Northeast. But vaccination and previous COVID-19 infections are no protection against XBB 1.5, but can reduce symptoms of severe infection. And actually, for most people, the symptoms of XBB 1.5 are the common cold nasal symptoms. So if your previous experience with previous COVID variants are likely to be much more severe than with this variant. And it's going to be hard to avoid getting this variant. I don't think there's anything you can do to avoid getting it, frankly. And there's an antiviral drug, Paxlovid, which is only recommended for individuals with a high risk of severe disease or death. So anyway, my proposal is to exercise, get adequate sleep, get a healthy diet, take supplements that boost the immune system like omega-3s, vitamin D, C, E, zinc, selenium. Stay up to date with COVID-19 vaccines, but catching subvariants will actually boost my immune system and yours probably if you've got a healthy immune system. So, are there any questions on this section?
The question is, given that the Omicron subvariants evade previous vaccine-based immunity due to mutations in the spike protein, do you think it would be possible to develop vaccines that do not rely on the spike protein?
Yeah, sure, it's possible. I mean, the Chinese vaccines have all the epitopes. I mean, there has to be an antigen against the antigen that's somewhere on the virus. The spike protein is the most logical place, most easiest place. But as I say, the Chinese vaccines have all four epitopes that are on the virus, and these epitopes to provoke the antigen. So the answer is yes, but I think the mRNA vaccines against the spike protein have been the very most effective.
Regarding breakthrough infections, even though vaccines can't prevent all infections, especially with some virus variants, don't they nevertheless reduce the seriousness of infections?
Yes, I said that.
Yes.
Even though they don't prevent the infection, they prevent severe disease and death.
Yes. Another question regarding COVID technology. Do you recommend people wearing a good quality mask, N95 or KF94, in crowded indoor meeting places, or should we be more relaxed these days?
I think you're actually better off getting XBB.1.5 because it actually it's proven that people who get the disease, their natural immunity is stronger than the natural immunity of people who've been vaccinated. So if you've had COVID, you should actually be more protected against severe disease and subsequent infection than if you were vaccinated. As far as the masks are concerned, I mean, if you have a healthy immune system, there's nothing to fear about. I mean, the XBB.1.5, which is taking the USA by storm, and it's just like having a common cold, and having gotten that virus, it will boost your immune system. So actually, I don't bother wearing masks, and the Delta is long gone. These previous variants are no longer, the Omicron has displaced all the really serious disease COVID variants. And I think I personally and many other experts I know are not bothering to wear masks.
Ben, here's a question.
Maybe another variant coming along. So if that happens, but currently with XBB.1.5, I don't think that's a concern.
Okay, thank you. Not sure if you have the answer to this, Ben. Are people that are transhumanists getting the vaccine, or are they staying away from the vaccine? Your opinion on that?
No, I can't comment on that.
Okay. Another question. While the Omicron subvariants continue to mutate and evade previous immunity, do you think there is a risk of an indefinitely ongoing pandemic with major waves of repeat infections every few months, unless some technological means is found to eradicate SARS-CoV altogether?
Well, I mean, there's possibility of having protection against all vaccines. There's various developments being done on that. But as far as the trend is concerned, the trend seems to be less severe disease and greater transmissibility. And so as long as that trend continues, I don't think Omicron is a really serious worry anymore. But that's I have no crystal ball in the future. I don't know. But the Ebola virus is much worse than COVID-19, but it's so lethal that it can't spread. It hasn't, it doesn't have it's not very transmissible.
Yes. I have a question from the live stream now, Ben. Gentleman is asking, should I stop taking any of my medications before getting a COVID-19 vaccine?
I don't know what medications you're taking, and I don't want to take responsibility for telling you things your doctor should be telling you.
What do you think about the hostile opposition by many Chinese authorities, but also by various scientists from elsewhere in the world, against suggestion that COVID might have originated from an unintentional lab leak? Do you have any comments on that?
I think there's a lot of evidence either way, but I'd rather not comment on the subject.
Okay.
Go back to where you were going.
All right.
So I'm a director of research oversight for the Biomedical Research and Longevity Society, formerly called the Life Extension Foundation, which is now spending about $10 million a year funding cryonics-related research. But I'll also give an update on I'll give an update on what I'm overseeing, but I'll also give an an update on general cryonic services. The BRLS, the organization that I do oversight for, funds these organizations, 21st Century Medicine, Advanced Neurobiosciences, Nectome, Biostasis Technologies, and related companies, and Suspended Animation, which gives SST services. So I'll talk first about 21st Century Medicine. The main current goals are to perfuse a rabbit kidney with vitrification solution, cool the kidney at cryogenic temperatures, rewarm the kidney, and then transplant it into a living rabbit with full function. And they also want to get similar results with rabbit brain and also study the transcriptome, proteome, and metabolome of tissues subject to vitrification solution and to determine the mechanisms of cryoprotectant toxicity. I'm only going to talk about the first aim in this presentation because this has been the major work of the chief scientist, Greg Fay, the last 4 decades. That's the main focus of 21st century medicine research. Kidneys are the most transplanted human organs, but the demand is greater than supply, and most patients wanting a kidney transplant die while waiting for a kidney transplant. And being able to vitrify and store human organs at cryogenic temperatures would both meet a great medical need and be a proven principle of cryonics. And this breakthrough would attract huge amounts of commercial funding into cryonics-related research. And vitrifying rabbit kidneys is the first step toward vitrifying human kidneys. So what is vitrification? It's quartz and sand are crystals, not glass. But if you add soda or lime to silicon dioxide, it makes soda lime glass, which is like window panes or the drinking vessels we have, beverage vessels. And if you watch a glass blower, you'll see that instead of forming cooling silicon dioxide forming into a crystal, it forms into an amorphous solid. It sort of just becomes like a thicker liquid. And vitrification does not cause cryoprotectants to cause the mechanical solid damage that result from ice crystal formation. So this is what we're trying to avoid, is freezing damage. And vitrification of organs means cryogenic below 100 degrees. Is the definite threshold of cryogenic is minus 100 degrees Celsius without ice formation. So we use cryoprotective agents, and they compete with hydrogen bonds. Water is H2O, as you may know, and the CPAs interfere with the hydrogen bonding of water molecules. So anyway, these are the major CPAs, but unfortunately, they can be very toxic, and that's a problem. So cryoprotective toxicity, chemicals presenting ice formation for antifreeze biological tissues, basically. And if cryoprotective toxicity could be substantially reduced, transplantable human organs will be stored at low temperature, and cryonics patients could be more easily preserved at cryogenic temperatures without ice formation. The challenge of preserving temperatures in organs with CPAs is to use enough CPA to prevent the ice formation, but not so much as to cause damage by toxicity. And if CPA toxicity did not exist, CPA could be used in larger quantities without worrying about ice formation or cooling or rewarming. So actually, kidney was vitrified in 2003 and cooled to minus 135, rewarmed, and transplanted into a kidney and able to sustain the function as a sole functioning kidney. But incompletely. There was damage to the kidney nonetheless. But anyway, there's only one kidney been done since 2003, and the kidney was damaged, as they say. And then there's been a lot of problems over the last decade to prevent this the replication. There's the 21st century medicine moved into a new building, and the manufacturer of ATS stopped producing that ingredient, and a rapid surgeon left, and they had to find another project such as whole body vitrification demanded at the time of 21st century medicine researchers. Now the kidney has a special problem. The kidney cortex receives 90% of blood flow, whereas the kidney medulla only 10% of blood flow, and intermedulla only 1 to 2%. Therefore, the cortex can be exposed to toxic concentrations of M22, which is 21st century medicine vitrification solution, before the medulla has received a concentration of M22 sufficient to vitrify. However, M22 can enter the medulla through the kidney filtrate into the urine, as well as through the blood vessels. And so this is showing the path of the ureter. It's not just the blood vessels, it's the fact that it can enter the ureter, and normally water and anything that's in the water will be reabsorbed, but at 0 degrees centigrade with these extracted rabbit kidneys, there's no kidney reabsorption, so we are able to get higher concentrations of M22 into the medulla. Now, ice nuclei is a problem. So actually, pure water doesn't freeze, and we see ice all around us on the cold days, but actually pure water will not freeze above minus 4 degrees Celsius because there's no ice nuclei. There's all sorts of nucleating agents, mostly bacteria, are the reason we see ice instead of at 0 degrees Celsius rather than at minus 40 degrees, and because of the nucleating agents. And silver iodide has a structure similar to ice, and that's why they can see rain clouds causing nucleation at 5 degrees, minus 5 degrees. So nucleation of vitrification solutions can become very high at cryogenic temperatures. And this shows the range. The nucleation temperature is very high at minus 120 degrees Celsius, and the ice growth temperature is very high at minus 70 degrees Celsius, or minus, anyway. And so the point is, when you're cooling the kidney or whatever organ you're trying to perfuse, you can not worry about ice growth in the initial stage because there's no nuclei being formed as you're cooling. The big problem is the nuclei form as you get into cryogenic temperatures, and then when you try to rewarm, then all those nuclei start causing all this ice growth. So the big problem is with rewarming the kidney, not with cooling. So Brian Wolk has developed a radio frequency rewarming for kidneys. Higher warming rates mean lower and therefore less toxic concentration being used for M22. So a radio frequency warming of 40 degrees per minute means you get no ice with 8.83 molar M22. But with 60 degrees Celsius per minute, you can get no ice with a lower molar concentration of M22. So and also the radio frequencies that can develop are function rewarming radio frequency is dependent on the temperature you're at. But anyway, this is a complex subject, and 21st century medicine is still working on all these problems, and that's enough said. The CPAs used by Cryonics organizations, BM1 is the Cryonics Institute, and M22 by 21st century medicine. M22 has a lot more stuff in it, and as you can see. And so VM1 is stable it's stable in tissues at dry ice temperature. So there's a little danger of ice formation of patient well perfused with VM1 in dry ice. But I say well perfused. This was a topic of discussion earlier today, meaning that many patients are not well perfused with VM1, so there could be ice formation. And VM1 is more toxic than M22, but M22 is not stable in dry ice for more than a couple of days under optimal conditions. And we don't even know what those optimal conditions are because it hasn't been standardized or defined. So authorities on the subject do not recommend shipping M22 patients in dry ice. So, as I say, if cryoprotectors were non-toxic enough to use in quantity, there'd be no ice nuclei formed, and we wouldn't have to worry about ice formation. But as I say, VM1 is more powerful cryoprotectant, but it's more toxic. But M22 was developed for medical applications, namely cryopreserving kidneys, particularly. Vitrification perfusion followed by dry ice shipment could be safe. I say can be safe, not necessarily safe. VM1, but not M22. So Advanced Neurobiosciences, we're also funding the Sasha DeWolf's organization, research organization. It aims to safely open the blood-brain barrier to improve vitrification solution perfusion of the brain, aims to find newer, less toxic vitrification solutions, and vitrifications used by M22 and VM1 have not changed in a couple of decades, and also find low-cost means of preserving by fixation. So the blood-brain barrier is different than normal blood vessels are not as tightly bound as blood vessels of the brain, and they're distinctly protected against allowing components of the blood from entering the brain, and it's the reason why VM1 and M22 can perfuse the brain without anyway, but it causes deep hydration, which can and also can prohibit cryoprotectant solution from entering the brain. Detergent STS can open the blood-brain barrier with reducing brain shrinkage, allowing more cryoprotectants to enter the brain with the risk of edema in cryonics patients. So Ashram is really keen on using STS in cryonics patients, but we need to be very careful that cryonics patients aren't very ischemic, which too many of them are, because that can create edema and defeat the purpose. So also looking at other possible different molecules. For, as I said, the CPAs used by the Cryonics organization and the research, 21st century medicine hasn't changed in a couple of decades. So Ashram A and B is wants to look at better, other possible cryoprotectants, carriers, and also improve the carrier solutions, because the carrier solutions are required for CPAs to ensure isotonicity. And studies on carrier solutions reducing CPA toxicity haven't been done since the 1980s. Anyway, this is a bit technical, but this is a possible carrier solution for improved carrier solution for reduced toxicity. And I guess it's too technical when you're trying to try in detail. Nectome, it's another organization which BRLS has been funding, Vancouver, Washington. It's doing research with the aim of improving techniques to use aldehyde stabilized cryopreservation as a means of low-cost human cryopreservation. There's a brain preservation prize, and because vitrified brain tissue does not produce electron micrografts that look identical to normal brain tissue. And so this foundation offers a cash prizes of a brain preservation technique that can be expected to keep brain well preserved by electron extension for at least 100 years. And in 2014, the 20th century won the Small Animal Prize, and 2016 won the Large Animal Prize for a combination of aldehyde and cryoprotectant. And this was the work done by Robert McIntyre and Greg Fay. And here's the paper which they describe the results. Rabbits and pigs were infused with 3% glutaraldehyde for 40 minutes using STS to open the blood-brain barrier, sodium aside, prevent myocardial swelling. 65% ethylene glycol was then added to the fixer solution for 4 hours, a linear ramp, followed by 1 hour of recirculation. So the Brain Preservation Prize judges Ken Aworth and Sebastian Sohn believe the brain preserved with ACS show an intact connectome, whereas the electron micrograph of vitrification show no structure. The connectome is the part of your nervous system that's basically you, that creates your cognitive facilities and memories and identity. Anyway, Dr. Fay believes that judges do not understand reversal of dehydrated vitreous-like structure, and it's conducting experiments in 21st century medicine to demonstrate that structure is preserved for brains vitrified with subsequent unloading. Now, Robert Fadis has written this large book, Cryostasis Revival, which describes how nanotechnology can repair the cryonics patients, which are suffering from various kinds of damage. But to Robert McIntyre, has stated, who's behind Nectome, has stated publicly that vitrified cryonics patients cannot be restored to life. But there was one Alcor patient, Dr. Stephen Coles, who lacked sufficient funding to become a standard Alcor patient. And so he became an Alcor neuro charity case based on allowing Alcor to do experiments on his brain. And after a standardized vitrification and cooling protocol with storage at minus 40 degrees Celsius, brain material was biopsied and examined, and there's no detectable ice damage or fracturing, and histology as well as ultramicroscopy indicate preservation of the connectome, connections of neurons encoding mind. So there's Robert McIntyre at Nectome in the Nectome office with a photo I took, and he left 21st century to found his company Nectome, which is dedicated to advancing aldehyde stabilized cryopreservation protocol. And I showed him here. This was when I visited his Washington office, and that's his lab. And he had a brain bank of 5 human brains, one of which was obtained by the Oregon Death with Dignity laws. He was not satisfied with quality preservation, but he said the quality is superior to brains in the Harvard University Brain Bank. And he's working with Jacob Hoekstra and various organizations in the Netherlands to take advantage of death with dignity laws and institutions of that company to apply ASC procedures and provide resultant brains to brain banks. So in early October 22, I observed Robert McIntyre attempting to perform ASC on 2 brain pigs with promising results. In doing pig experiments to stimulate death with dignity situations, rapid fixation without lethal injection. Once his technique of ASC is perfected, Robert McIntyre wants to start an ASC company offering services to cryonicists ending their life under death with dignity circumstances, eliminating the need for expensive standby stabilization and transport. So anyway, cryonicists dying under death with dignity circumstances would likely be elderly persons with ischemia associated with the dying process, unlike healthy pigs. ASC candidates will be a small fraction of the Cryonics market. Robert McIntyre is limiting his clientele to death with dignity persons to duplicate the non-ischemic results that won the Brain Preservation Prize. And how much ischemia compromises the quality of the ASC has not been determined, is not being studied. Tomorrow, Biostation wants to offer a version of ASC as a low-cost option, probably under ischemic conditions in most circumstances. Organ Cryonics offers chemical preservation of brains for years, although under ischemic circumstances. So, the glutaraldehyde cross-linking of brain tissues is irreversible. Most advocates of ASC believe their brains will be uploaded from their ASC-preserved brains into a computer. In my opinion, there's no path forward to uploading a fixed brain or mind to a computer, and if there's a path, is orders of magnitude more difficult than repair of Cryonics patients. Now, this is my opinion, I emphasize. A fixed brain would probably be more easily repaired by nanotechnology than uploaded to a computer, my opinion. And minds purportedly uploaded to a computer might simply be a simulation of a person lacking the qualia of self, and there would be no objective means of differentiating the two. In other words, you might have a computer purportedly having uploaded yourself, and no one can distinguish between the self that they see in the computer, but there's no self in there. It's just a simulation. Anyway, mind and software could easily duplicate qualia. So if we have software that can be uploaded to a computer and be a person, you can make billions of copies or more. But you can say the same thing about biological humans in theory. And now, Biostasis Technologies in New York, which is the event we're currently attending. So it's doing full-time research on the needs to improve Cryonics SST, Standby Stabilization Transfer Service. VT will test commonly used CPS devices, Lucas 3, Corpals, CPR Allpulse, seeking quantitative measures of performance for comparison. And BT will also develop the development of liquid ventilation devices for use in Cryonics cool down. So faster cooling is better. Ischemia is tissue damage due to lack of blood circulation, no oxygen, CO2 buildup. The faster Cryonics patient will be cooled, the less ischemic damage occurs to tissues. Cooling in an ice bath is faster than cooling with ice bags. Temperature conductivity, due to temperature conductivity of cold water. And actually, if you circulate the cold water, you get even faster cooling. So that's what a squid looks like in an ice bath. That's a cooling arm. And so this shows you the comparison. The top line shows the ice bags, the middle line shows the ice bath, and the bottom line, ice bath with a squid where the water is circulating. So you see that it takes about 3 hours to get to minus 20 degrees with the ice bath, whereas with the squid, you can get to within about 2 hours, you get to minus about 15 degrees. Internal cooling is faster than external cooling. If you can cool a patient with cold fluid in the blood vessels, it gives you very fast cooling, but requires surgical access to the blood vessels, which takes time, so requires a standby surgeon. So cooling with liquid gas mixture through the lungs could potentially be done rapidly and without surgery. So this is showing the cooling through internal cooling through the blood vessels, which requires surgery, the femoral artery and the femoral vein, whereas this is showing a theoretical example of 6 minutes of 11 minutes. It takes about 11 minutes in this example to cool 6 degrees Celsius with liquid ventilation, as opposed to 30 to 40 minutes cooling with external cooling. So this would be a big boom. And this is an LV5 used experimentally on dogs the liquid ventilation system built by Charles Platt. And it reduces the emergency of standby surgery, eliminates the initial time required for surgical access, and it has a VT is contracted for an automated portable LV device, LV5A. I say you can say A for automation, but that's not really why it is. To be built for human cryonics cases, not simply dog research, which is what LV5 was only used for. And it will test the LV5 device on cadavers to suggest further refinements. And more than one LV5A will be made so it can be used in practice in cryonics cases. So now I'm going to have a section on vital signs alarm systems. I'll do the first part, and Nikki Olson will do the second part. I think I misspelled her name. Anyway, since 2004, I've had a page on cryonics in the cryonics section of invest.com website. I talk about personal alarm systems, cryonics. I made updates every few years, now totaling 18 updates. I've seen very many promising developments followed by many disappointments. I might mention less than half of cryonics have arranged for standby have actually received standby at reanimation. Most of those who receive standby or cryonics is dying of cancer, and most people don't die of cancer. Most worrisome is sudden cardiac deaths, which between the ages of 20 to 64 primarily affects males, but after those ages affects females roughly with the same incidence. So, and then I've seen many cryonics living alone. I know cryonics is the patient Hugh Hart, who died on a Friday, not discovered until the following Monday. Alcor patient FN 2022 was dead for about a week in his apartment before his discovery, and many others have suffered from a premature death. And even when you're not living alone, a cryonics-friendly spouse could awaken to discover a cryonics spouse dead in their bed. I know one CI activist who was discovered by his spouse lying on the floor of the kitchen in their house. He'd been dead for hours. So, panic button systems could help. Some elderly cryonics is laying on the floor who could have been saved by panic buttons. Just push a button and get 911 to be called. Panic button systems can alert cryonics as well as 911. 911 can give chest compression and ventilation while driving to the hospital, even if the heart has been stopped. And declaration of death can be obtained in the hospital. Cryonics can rush to the hospital and begin cooling. So this is one of the good panic button systems, one of the best panic button systems I've seen, mobile help, and it's 24/7. It's got a 20 call center, and it's got a base station with a large range, 1,000-foot range, and the mobile unit has 600-foot range, and it has fall detection and GPS, 24-hour battery life. And if you've got the mobile unit, you fall unconscious on the street because of the GPS, emergency personnel would come. So, and also, if you're going to die in your apartment, it's good to have a lockbox on your door so that emergency personnel don't have to break down your door. And so give the lockbox combination to these call centers. So these are what I call the desired features of an ideal vital signs alarm system. Rapid detection of loss of vital signs, notably heartbeat, a convenient, comfortable, convenient use. You can even while bathing, sends messages by phone numbers, emails, preferably including a call center. GPS is identified and transmitted with a message, low power consumption, convenient to recharge, wirelessly operational anywhere, and false alarms, minimal and easily handled. So every year I've been going to CES this computer electronics show in Las Vegas, looking for promising vital signs equipment. And so I went this year and I found a few promising products. This was a sensor skull. It's actually a motion detector that you mount. An elderly person can mount this motion detector, and it gives a notification to relatives and a call center, I guess, for about when there's no activity. I guess it would be disabled when the person is sleeping. I was impressed by this body log bed. I put my hands on the bed, and it displayed my electro EKG was displayed on the screen. So, and they told me, and I've heard this, it's a Korean organization, but they tell me, I always hear this coming soon, but they say within 3 months they'll have capacity for notification, and eventually they hope to get it in the United States. And this MSL also has to, this is something you can wear on your chest. The person at this booth was wearing one on her chest, and was showing her electrocardiogram vitals were being displayed, and there's it has a facility for notification if there's an electrocardiogram abnormality, heart failure of kind, and so there's a notification, but it's only Korea. I really have felt for years that the reason why so many of these products, promising products, are not reaching the American public is because the FDA is really conspiring to kill us, at least Cryonics, by requiring too much, raising the threshold too high for our use. But actually, the woman at the booth emailed me and said she could possibly even get around the FDA and get me a product. But I don't know, I don't know how well that will work. But anyway, I'll see what happens. And this was a final. This is actually a vital signs. This is in the UK. And once again, we're not in the United States, and they don't. But it seems like it's a vital signs watch, and they can send notifications, but it's not in the U.S. And I guess they want to get in the U.S. All these companies want to get in the U.S., but the FDA is standing firmly with their hands blocking the door. Anyway, I just want to indicate that we don't just need watches or chest monitors. We also have, we can detect heart rate in the ear. So anyway, I want to introduce Nikki Olson, who's been working on the subject vital signs alarm. So that's Nikki, and she's a Cryonics Institute member and a professional software developer seeking to implement vital signs alarms. And to show you some of the kind of testing she's done, she's put she's got these are 2 Fitbits and 2 Apple Watches that she put on drumsticks, chicken drumsticks, and got vital signs readings on all of them. So anyway, with that, I'm introducing Nikki Olson. So take it away, Nikki.
Today we're celebrating Bedford Day, and it's a day of celebration. And so I wanted to have an optimistic presentation here on the progress of Cryonics monitoring in 2022. So who am I? I'm a software developer in the Seattle area, and I've worked with wearables and this issue in particular for about 2.5 years. And I've developed, prototyped, and tested multiple products for Cryonics purposes. I'm doing ongoing research into potential solutions. I'm working on my own solution, which I will get into more later. And I'm also a member of the Alcor Research and Development Committee. So I've chosen 4 technologies specific to cryonics to highlight today. The first, Gene Shaver Fitbit HR heart rate based alarm. The second, the biostasis releasing of their beta version. Third, my own correspondence with a company called BioBeat, who has an impressive AI detection system, and also my own multi-sensor Fitbit Sense solution, which I'm in the process of developing. So this is Gene Shaver's application. You'll see this when you install it onto your Fitbit Sense. Essentially, he's looking at heart rate, and then at the moment that the watch can't detect a heart rate, it sends out an alarm to your contacts. Phone them, text them. There's various configurations that you can have there. And this, as Ben showed earlier, is part of the experimentation that I did this summer. Gene's implementation is on the top right here. That's a Fitbit Sense. Below that is Fitbit Versa 3. And then on the left it's 2 Apple Watch 6s, and they're different software versions, but both the same hardware. And you can see they get different heart rates, even though it's the same type of inanimate object. And so I guess the general message here is to, be cautious when you think about using light-based heart rate measurements on these kind of consumer-based fitness devices, because there are issues. So from some testing that I did on Gene Shaver's application, I know this is too small to see on the bottom here, but the majority of these testing iterations ended up in about the 3.5 to 4 hour range in terms of how long it took from when the watch was placed on the inanimate object to when the Fitbit decided that it couldn't find a heart rate. And that seems like very bad, but currently we have like check-in apps that are like checking on you once every 24 hours. And so actually 3 hours is a substantial improvement over the current state of things. And in some cases, it did sound the alarm fairly quickly in like the 15-minute to 30-hour or 30-minute range. And so it depends. They're not reliable, but in this case, like I'm saying on the next slide here, that I think it is worth using if you need something right now. I think it does on average improve the time it takes for the alarm to go off versus a check-in app. And that's also assuming that you use it correctly, because there's these issues with things like Ben was saying. It'd be ideal to have Wi-Fi or be connected even through like cellular network, but with Fitbit, it's unfortunately Bluetoothing to the phone, and so you have to keep your phone fairly close. Also, software updates may change the way this graph may shift in various ways on the next software update, and so this kind of strategy actually requires a software development engineer and test to continually be evaluating it. But it is relatively easy to use, and I think a stable product. And the great thing about Fitbit is it does have a good battery life. And so you can contact Gene Shaver if you'd like to try that out. He's with the Minneapolis Cryonics team. I can't remember the full name, but you can also contact me if you'd like to connect with him. Moving on to the Tomorrow Biostasis monitoring app. They just moved this into beta late this past year in October and November. And you can download an Apple version or an Android version from their main website. And so I've tested this out a little bit. Some of the details, it is a phone application. And so basically you'll have your selection of what wearable you want to wear. Your wearable communicates with Apple Health or Android Fit. And then from there, the Biostasis app will pull that information and make its decisions. It is based on heart rate, and it will basically look, if it doesn't see a heart rate in that log of data for some period of time, it will sound the alarm, is my general understanding of the design here. And so another nice feature is you have the ability to upload your Cryonics documents for whoever might be coming to check on you. It also has a very nice contemporary UI, and it has the check-in and timer features that you find in the Cryonics Institute and to some extent in the Alcor check-in app. And so it has a lot of nice features. But there are issues. As I said, it's still in development. Actually encountered a lot of bugs in the current iteration. And so if you're trying it out, just keep that in mind. And it also matters which wearable you use. So like we looked at with the inanimate objects, the drumsticks, some of the wearables are better than others in handling that situation. For instance, there's been some Samsung Galaxy watches that I've tried out that detected inanimate objects almost immediately, whereas the Fitbit tends to take longer. Apple Watch seems to be getting better. The Oura Ring seems to do a fairly decent job. And so it is going to matter which wearable you choose for a heart rate based solution like this. You also have to worry about delays due to syncing. And so the Oura Ring 2, for instance, I believe it doesn't sync during the night at all until you open the app. So that's not going to work if you've passed away during the night. There's also delays in trying to glue things together. Basically, the app has to talk to Google Fit, and then the Biostasis app has to talk to Google Fit. There's many pieces, moving parts, and there's delays in how those things are, how frequently they're updating with one another. And so it might not be a very timely solution from that standpoint as well. So in general, I'd say this kind of design strategy has some kind of unmitigatable false positives and negatives, though to some extent, it's device dependent on how bad those kinds of problems are going to be. And this is the one that I'm the most excited about. This is BioBeat, which I was in contact with them a lot this summer, trying to figure out a possible way to work a cryonics alarm with them. And I think this is kind of the shape of the solution that we all want, which is to not only detect death, but also detect a problem before it happens. So leading up to when you might have some kind of event like a stroke or a heart attack, to be able to discover changes in vital signs that would indicate that a problem is coming. So they have this AI-based early warning score system that they're doing, where they basically have machine learning and a convergence of all these different kinds of vital signs to, it's a proprietary closed system to, develop these risk-based numbers. So you can be high risk, low risk, and go from there based on the number on how you want to bring in the cryonics monitoring. And so they measure quite a few things, a lot more than the Apple Watch, for instance. And they're also measuring blood pressure, which is something that you don't usually see on a wrist-based, light-based monitoring system. And they're not just claiming to measure these things either. They actually have FDA clearance for a lot of those things that they're measuring. So blood pressure, pulse rate, oxygen saturation, respiratory rate. They've gotten clearance that what they're measuring is accurate enough in the way that they're measuring it in order to sell it in this way. So I think that's like very encouraging. They've surpassed Apple in this way. So how are they doing that? They have proprietary hardware. So their light-based sensor on the wrist is proprietary, somehow better than what Apple's doing. And they also have their own kind of machine learning and software on top of that to process this. It's very noisy data. People move around a lot. The data has a lot of motion artifacts in it. It's very difficult to process that data and discover like a heart rate within it. And they're doing a very good job at, somehow filtering out the noise and finding the essential patterns that they need. So I think it's very exciting what they've done there. But because they've obviously invested a lot in making these kinds of leaps, they have a strict way of selling this. They're selling basically business to business only. I can't buy the device and work on it as an individual developer. It's not open source. There's nothing accessible to me. The cost to start trying out these devices is fairly high. It's $5,000 plus to start the process. And they have no calling system in place. But in speaking with them, they have other clients they have some flexibility on how you can integrate with their system and build software on top of their system or, interface with their system so that we could add a calling mechanism or some way to make the notifications more apparent, because right now it's just desktop software. The other issue is that it's not actually designed to detect death. It's designed to detect the deterioration. And when I asked them about this, they said, well, we don't actually know how it behaves in that context. Light-based sensors tend to be inaccurate under 20 beats per minute. And so this would require testing as well. But I think with all of the very complex processing they're doing on these light-based signals, I would think that they are probably doing a pretty good job on that, or we could somehow use the raw data to try and solve that issue as well. So in summary, I think this is a very exciting and encouraging product. Even if their business model is not going to work or it's not affordable, I think that like the fact that it exists and that someone has been able to do this and measure these things so accurately and develop the system, if someone else does it, it'd be great. And we'd probably want to use it as cryonicists. And so this is my last thing. This is my solution that I'm working on. Basically, I'm looking, in the meantime, before we can develop something more ideal like the BioBeat, I'm looking to develop something that is reliable, that will work for those who currently need something. And it is based on the Fitbit Sense. And basically, on top of what Gene is kind of built on, I'm adding in motion detection, basically continuously monitoring all the small motions that you make with your wrist. And so more of the features are this is what I'm going to call a smart motion analysis, which is it's going to consider how you in particular move, the times you usually take naps, how long do you sleep during the night without moving, so that we can narrow this window of like when we expect you to move. And so if you basically are always moving during the day, you're not a type of person who takes naps, then maybe we can sound an alarm for you after you don't move for something like 30 minutes. But also using heart rate as well. So if that alarm starts to get triggered by heart rate, either high or low, or the absence of heart rate, we can sound the alarm that way as well. So we have both features. And in the case of my design, I think it's going to be exceedingly rare to have a false negative beyond that 1 to 2 hour point, like during the night when you're not moving in your sleep, if you're using it correctly. There's like some edge cases that I can think of that kind of torment me, like an animal jumps in the bed and like moves, jumps around and it looks like you're moving, or there's these edge cases. But in general, I think it's going to be a kind of foolproof kind of system, especially for people living alone. And as with Fitbit, good battery life, easy to use. And shout out to the developer who is working with me, Philip Bartels. He's been taking on the front end web portion of my development, which both of us are back end developers and we don't like doing front end. And so he's actually just toughing that out and doing it. So thank you to Philip. This is an example of the web component that he's building. Eventually we'll also have a companion app, so you can enter this on some app on the phone, but for now it'd be web-based for our version 1. This project will eventually have infrastructure costs for the database element. There'll be cost of testing it. And Philip and I are both time constrained with job commitments. And so we will be seeking funding at some point once the prototype is further along to cover those costs. And so right now it's currently being worked on in a part-time capacity. So yeah, I wanted to just close this by saying that I'd like people to get in touch with me if they want to send me links or they have questions about any of these devices or the products that are in existence. Also that they should join the hunt. Like Ben Best had mentioned, he goes to CES every year trying to find potential solutions. And also for the software developers out there in Cryonics, which there are a few, if you want to get involved and help me with the development of the one that I'm working on, or also if you want to be involved in testing, then please reach out to me and get involved. And so, yeah, that's all I had.
Thank you, Nikki. Ben, earlier in the talk, this relates to your talk earlier. What problem would you speculate would it still exist with plantations if a perfect respirocyte were invented? Do you have any comments on that?
No. I don't have any knowledge of respirocytes.
Okay. A question for you, Nikki. How likely do you think artifacts from current Fitbit Sense devices could result in strange heart rate readings, for instance, a spike in the heart rate for a few minutes that may not correspond to reality? If this is a possibility, what do you think the cause would be in terms of how the device operates?
So what they tend to do, and I've looked at some of the algorithms because there are some open source algorithms that read this kind of data and process it, is they tend to run a filter and process out all the really high and really, first step they do is take out all the really high and low readings, because they are kind of assuming those are a malfunction. And then the other reason, so the reason that you get those kinds of incorrect readings is when you're moving around a lot. And this is a big problem for them because they're targeting the fitness industry and people are wanting to know their heart rate when they're moving. So they're really honing in on that problem. That's why they're not good at what we want them to do, is because they're trying to solve that problem. And so I think it's uncommon that you're going to get a really, really high reading when you're not actually having a problem. But the upper limit is, I think, 220 in terms of accuracy for what they say. So, yeah.
Ben, how long before there is likely to be a new successful experiment with a reanimated rabbit kidney?
Well, we've been hoping for this for years, but I think the progress I've seen in 21st century medicine makes me think it is very, very good chance that they could achieve success in 2023.
Okay, thank you. Another question for you, Ben. You gave some arguments to prefer cryopreservation over chemopreservation, ASC, but can you foresee circumstances in which you might change your mind about that preference?
No.
Okay. Is there a case to fund cryopreservation and reanimation of a small animal that is a bit larger than C. elegans worm?
Well, I've long been interested in seeing, I guess you want to demonstrate retention of memory, and I've been really interested in the tardigrade. The tardigrade is well known to resist very low temperatures, and it also has a brain similar to animal brains with two hemispheres. And I'd like to see somebody train a tardigrade and demonstrate that, and cool at cryogenic temperatures and demonstrate that it's retained its memories.
That would be a worthwhile experiment, Ben. I hope that can come to pass. All right. Ben, you've given a great presentation tonight, and Nikki, what a wonderful presentation you've added. We thank you both for your great presentation in this celebration of Bedford Day. Thank you very much. I want to remind everyone that we will be meeting again at Perpetual Life for our regular service, which will be on January 26th at 7 p.m. when we have Brian Clement from the Hippocrates Health Institute out of Palm Beach giving a presentation. That'll be both live in person as well as through Zoom. So it'll be both ways. Thank you, Ben. Thank you, Nikki. Thank you all.